Do you want to do the chain rule as well? Is that a yes? Hi, welcome to the STEM Girls, and this is Alicia. This is part of a series that deals with the chain rule. So if you've missed the first video or you don't know what the chain rule is, please click the link below. Okay, so for our first example, what we're going to do is we're going to differentiate y equals sine 7x plus logarithm 5x. And obviously we're going to use the chain rule to do this. So what we already should know is that we should differentiate the outer and the inner function separately. However, we can see that there are a lot of layers to this problem and that we need to differentiate a lot of different terms separately. So let's just look at the layers from the outside in. The first layer would be the square root, then it would be the sine function, then it would be the 7x plus logarithm, and then last of all it would be the 5x. So we need to differentiate 4 different terms and remembering each time to keep the inside part the same. Okay, so now let's look at this and differentiate the outermost layer, which would be the square root. So to differentiate the square root, we would change it into brackets. So now that we've dealt with the square root, we have to deal with all the stuff that's inside. So what we do is we have to do the chain rule again. We're going to make this part into u. Then what we're going to do is we're going to differentiate in terms of the u. So it'd be over du of sine u and dx of all of this right here. So that's 7x logarithm 5x. Okay, so now what we have to do is we have to differentiate sine u, and sine u differentiated just equals cos of u. And so after that what we have to do is we have to differentiate 7x plus logarithm 5x. Yeah. So what we do is we split it into 2 sections. So first let's differentiate the 7x. We put the constant on the outside and then we just differentiate the x, which would just equal 1. So what we would then get is 7 times 1, which would just equal 7. Now differentiating the logarithm of 5x, again we separate them. So we differentiate the log equal 1 over u, and then we will just differentiate the 5x, which just equals 5. And now we have to join it all together. Now what we would do is times the 2 differentials together. So that would just be 1 over u times by 5. What we would do is we would substitute back the 5x equals u. So what we would get is 1 over 5x times by 5. And that would just equal 1 over x. What we have to do is we have to add the differential of 7x and the differential of logarithm 5x together. So we would just get 7 plus 1 over x that we got from here. So looking at what we have now is we have cos of u times 7 plus 1 over x. And we can simplify that further. And if we substitute back the original u, which was 7x plus logarithm 5x, we get cosine 7x plus logarithm 5x all times by 7 plus 1 over x. So all we need to do with this equation is substitute back the square root that we solved earlier. That would equal 1 over 2 square root u cosine 7x plus logarithm 5x times by 7 plus 1 over x. Now what we're going to do is we're going to substitute the u, so it would now equal 1 over 2 square root sine 7x plus logarithm 5x times cosine 7x plus logarithm 5x times by 7 plus 1 over x. And that is our final answer. And now we are finally done. I kind of get why my cat didn't want to do differentiation. Despite the fact it being so long and so tedious, it was literally the same thing that we did again and again. So we basically just differentiated different parts, substituted it in, and that is it for today. So bye.